Right, children. We are going to start the third chapter of this lesson. Do you remember what we learned in the first two chapters? We learned about the effects of magnets. Now we know that magnets can attract some materials, but some materials do not get attracted towards a magnet. And we learned there are different types of magnets. We use them in different instances as well. And we learned that the two ends of the magnets are known as magnetic poles, and magnetic poles have more magnetic power than the middle part of the magnet. And further we learned that there are two magnetic poles, north pole and south poles. And now here we are going to learn about the interactions between the poles of magnets. Now already we know that there are two magnetic poles, north and south poles, okay? At the same time, now we know that when we hang a magnet, the north pole of the magnet will always face towards the north direction and the south pole of the magnet will always face towards the south direction, okay? So this activity is testing the interactions between the poles of magnets, magnetic poles, okay? What do we need to do this activity? We need two bar magnets and we need a wooden stand and some pieces of string, right? Let's write. A wooden stand, pieces of string. Let's write string. Okay. Two bar magnets, wooden stand, pieces of string. How to do this activity? Look at the diagram. There are two diagrams here, X and Y. Look carefully. Look at the X diagram. Here the wooden stand is there. One magnet is hanging here. One magnet is hung. The other magnet is free, right? The magnet that is hung is labeled as A. The other free magnet is labeled as B, right? Fix the magnet A as shown in the figure. You have to hang the magnet using string to this wooden stand, okay? After it becomes still, now you all know that soon after you hang in this one, it will rotate and it will move here and there, and at one point it will become still, right? After it becomes still, bring the magnet B, the other free magnet, bring the magnet B towards it according to the instructions given in above Y. So you have to bring magnet B towards A in this method. Now you all know that magnet has two poles, north and south poles. When you look at these pictures, now you know that red side indicates the north pole and blue side indicates the south pole. So how do you have to bring them close to each other? Look at this method. Now for you all to understand better, I will write this is the magnet A. A magnet. This is the B magnet. Right? This is the magnet that is hung and this is the free magnet, B1, like here. Look at this one. This is the method you have to bring them close to each other. You have to bring the north pole of the B magnet towards the north pole of the A magnet, right? And then you have to bring the south pole or the blue side of the B magnet towards the north pole of the A magnet, right? And then third one, south pole of the B magnet should be brought towards the south pole of the A magnet. And the north pole of the B magnet should be brought towards the south pole of the A magnet, right? So number one, two red sides brought together, north and north brought together. Then north and south brought together. Both south and south poles brought together. And the south pole of A and north pole of B brought towards, right? So you have to observe what happens when you bring the two magnets close to each other in this manner. We are going to do this interesting activity now. Right, children. Now we are going to see how magnets interact with each other. So I already explained you all what to use for this experiment. We need two bar magnets and we need a wooden stand and we need a string. Why are we going to use the wooden stand again, children? That is because if we use a metal stand or an iron stand, what will happen? It will affect this experiment because magnets can attract iron. Okay, so in that case, we are going to use this type of wooden stand. Okay, right. First of all, I'm going to hang this string like this, and I'm going to hang one magnet using the string. So now you all know this is the North Pole and this is the South Pole. Every magnet has two poles. This red side, normally in these type of bar magnets, one side is colored in red, that is the North Pole, and the blue side is the South Pole, right? So then I explained you all what to do. First of all, I will call this magnet magnet A and this one magnet B, right? And then I have to bring this magnet towards the other magnet, one magnet that is already hanging, right? Now I will call this magnet B, okay? I am going to bring the north pole of this magnet B towards the north pole of the magnet A. Look carefully. What happens, children? They repel each other. So you all can see this magnet starts rotating when these two red sides grow together. This starts rotating. That is because this A magnet's moving away from the B magnet. Okay, see? Right. So then what I am going to do is I am going to bring the blue side or the south pole of this magnet towards the north pole of the A magnet. What can you all see, children? It instantly attracts towards, right? They attract each other. So again, if I bring the north poles together, what happens? They repel, they don't attract, right? And if I bring the south pole towards the north pole of the other magnet, they attract, okay? Now I'm going to bring the south pole of this B magnet towards the south pole of the A magnet. Let's see what happens. What happens, children? This A magnet starts rotating. That is because when two south poles, the south pole of B magnet and south pole of A magnet, when we bring it together, what happens? They repel each other, right? See, they don't attract. Now I'm going to bring the north pole of B magnet towards the south pole of this A magnet. Now, this time what happens, children? You can clearly see they attract. I will bring it again. They attract. Even if I take, so always north and south poles attract. So it's very clear after doing this activity, children, when the two north poles are brought together, brought closer to each other, what happens? They always repel. Watch again, they repel, right? And in the same way, the two south poles are brought together, again they repel. But what happens when north poles and south poles are brought together? They always attract, right? They always attract. So by doing this activity, it's very clear when same type of poles present, they always repel, which means north and north poles repel each other, south and south poles also repel each other. But unlike poles, when we take these poles, the same type of poles are known as like poles. So it's very clear, the like poles repel each other. What about the different poles or the opposite poles? These are known as unlike poles. South and north poles always attract. Right, children? South and north poles always attract, which means unlike poles attract. Right, children? So after doing this experiment, it's very clear, like poles repel and unlike poles attract. Right, children? So you observed what happened. What did we do again? So we have to hang one magnet, right? One bar magnet. And when it becomes still, we have to bring the other bar magnet towards the hanging magnet in this manner. First north and north poles together, then north and south poles together, south and south poles together, and the opposite south and north poles together. What happened, children? Do you remember how it behaved? What happened when the both north poles brought together? They repelled each other, right? Look at these arrows here, it's given. They repel each other. That's why these arrows moving away from each other, facing away from each other, right? What happens when we brought the south pole of the B magnet towards the north pole of A magnet? What happened, children? They attract towards each other, right? And then again, two blue sides or two south sides brought towards each other. What happened? Then again they repelled. Again, the opposite south and north poles brought together, they again attract towards each other. So this is what we observe when we do this activity, right? Let's write the observations. When the north pole of B magnet is brought towards the north pole of A magnet, they repel. When the north pole of B magnet is brought towards the north pole of A magnet, they repel. When the south pole of B magnet is brought towards the south pole of A magnet, again they repel. When the north and south poles of the two magnets when the north and south poles of the two magnets are each other, they get attracted. They get attracted. When the north pole of B magnet is brought towards the north pole of A magnet, they repel, which means north and north repel. When the south pole of B magnet is brought towards the south pole of A magnet, they repel again, which means south and south poles also repel, right? When the north and south poles of the two magnets are brought towards each other, they get attracted, right? So what happens when north and south poles brought together? They get attracted. But north and north or south and south poles, which means the similar poles brought towards each other, what happens? They always repel, right? But when the opposite or different poles brought together, what happens, children? They always attract. So what is the conclusion? After doing this activity, it's very clear. When similar poles, now remember children, these similar poles are known as like poles, right? Similar poles are known as like poles, which means north and north pole or south and south pole. When similar or like poles are brought together, they always repel each other. But when different poles, so these are known as unlike poles, right? Unlike poles or different poles always attract towards each other, right? Let's write that one. Like or similar magnetic poles get repelled. Unlike or different magnetic poles get attracted like magnetic poles or like or similar magnetic poles get repelled, unlike or different magnetic poles get attracted. This is a main theory of magnets. Okay, children, always when we consider the magnetic poles, there are two types of magnetic poles, north and south poles. When there are two magnets, when we bring the similar poles or like poles together, which means north and north or south and south poles, the two magnets repel each other. But if we bring the north pole of one magnet and the south pole of the other magnet together, they always get attracted towards each other. Understand? We have an assignment to do. When you are provided with an unmarked magnet, identify and mark the poles of it by using a marked magnet. Now, so far during the experiments, we used all the magnets, they are marked, right? Or red and blue side. Now we know that red side is the north pole and blue side is the south pole, right? So far we used all these marked magnets. What if we are provided with an unmarked magnet, children, where the north and south poles are not marked? How to identify the north and south poles of that unmarked magnet using another marked magnet? Okay, that is what asked here. When you are provided with an unmarked magnet, which means we don't know what is the north pole, what is the south pole, even like it's not indicated with colors as well. Okay, so identify and mark the poles of it by using a marked magnet. Now I am sure when you are provided with a marked magnet, using the attraction and repulsions of the magnets, two magnets, you can easily find out the north and south poles of the unmarked magnet as well. How to do this activity, children? Let's write. What is the main theory that we have to use when we are going to find out the unmarked magnet using the marked magnet? What is the main theory that we are going to use? Yes, we are going to use the attraction and repulsion of the poles. Now, we all know as a theory, the like poles repel each other, which means north and north poles or south and south poles of the two magnets always repel each other, right? And always the unlike or different poles, which means the north and south poles always attract towards each other. We are going to use that theory to answer this question. First of all, I am going to write that theory. I will write it in a different color. Like poles repel, unlike poles attract. Unlike poles attract. So this is the theory we are going to use. Therefore, I am going to mark it like this. Like poles repel, unlike poles attract. Using this theory, we can ask this question very easily. So how to do this activity, children? First of all, you can take the one side of the unmarked magnet, right? You can take the unmarked magnet and you can take the marked magnet, right? Let's say that we can bring the north pole of the marked magnet towards the unmarked magnet. So what happens if they get repelled? Now we know that like poles repelled. So when we bring the north pole of one magnet towards the unmarked magnet, what happens if it gets repelled? We know that the unmarked magnet, the side of the unmarked magnet also has to be the north, the same side, because like poles always repel, right? So it should be the north pole then. If it gets attracted, what will happen? We know that always unlike poles attract. So what happens? We know that when we bring the north pole of the known magnet towards the unknown magnet, what happens, children? If they get attracted, we know that if we have the north pole facing towards the other magnet, we should know that the other side is the side that present towards the other magnet is the south pole of the unmarked magnet, right? We are going to do this in the lab as well. First of all, we'll write down how to do this, right? Let's write. Bring the north pole of the marked magnet towards one pole of the unmarked magnet. If they get attracted, that pole of the unmarked magnet is the south pole, which means the other pole is the other pole is the north pole, and the other pole is the north pole. I will simply draw a diagram to understand this better. So we have two magnets like this. So let's take, this is the marked magnet, so we know that this is north and south. This is our unmarked magnet, so we don't know what is the side. So when we bring this one pole of this one towards the north pole, if they get attracted, so attraction I will show with arrows like this. If they get attracted, now we know that like poles repel, unlike poles attract. Unlike poles attract means only the dissimilar poles, okay? They attract. If this is north, this should be the south pole then, right? So if this is the south pole, when we take this magnet, if this is the south pole, this has to be the north pole, right? So this happens if they get attracted, okay? Right. Then, if they get repelled, what will happen? If they get repelled, that pole of the unmarked magnet is the north pole because they repel. North pole, and the other pole is the south pole. will draw a small diagram for this as well. If these two are the magnets, what will happen? If this is the known magnet, this is the unknown magnet. So what will happen if they get repelled? Here they get attracted, they come close to each other. This one they repel. I will put arrows like this. If they repel, they move away from each other. If they get repelled, right, like this, which means when they move away from each other, then we know that here like poles repel. So if this is north, if this side gets repelled, this one also has to be north. So if this side of the unmarked magnet is north, this is automatically becomes south. Understand, children? See, we'll go through the answer again. Like poles repel, unlike poles attract. This is the theory we use to answer this question. Okay? Bring the north pole of the marked magnet towards one pole of the unmarked magnet. If they get attracted, that pole of the unmarked magnet is the south pole and the other pole is the north pole. If they get repelled, see, if they get repelled when you bring this north pole of the marked magnet towards one pole of the unmarked magnet, if they get repelled, that pole of the unmarked magnet is the north pole and the other pole is the south pole. So it's very easy to find out the poles of the unmarked magnet using a marked bar magnet. We will go to the lab and do this activity. Right, children? Now we are going to identify an unmarked magnet using a marked magnet. Okay? So for this experiment, we need two magnets. One magnet I have here, you all can see, I have wrapped that magnet. So you all can't see the poles of these magnets. Okay? So this magnet, you all can nicely see the poles. This is the north pole. This is the south pole. So how to identify the poles of this magnet using this magnet, children? Let me show you. I am going to bring the north pole of this magnet towards this magnet. Let's see what happens. What happens, children? It attracts. See? Right. Now I'm going to bring the south pole of this magnet towards the same side of this wrapped magnet. There what happens, children? It repels. Right, children? This side repels. So you all saw that when we bring the north pole of this magnet towards this wrapped magnet, what happens? It attracts, right? And when we bring the south pole, it repels. Now you already learned that when we consider about the poles of the magnet, like poles or similar poles repel each other. Right, children? And unlike poles, so different poles or opposite poles attract towards each other. Right, children? So in this case, so when we bring the north pole towards this one, they attract. So according to the theory, what happens? Unlike poles attract towards each other. Right? So if this is the north pole of this magnet, this has to be the south pole. Okay? So we are going to write this one, south pole. So in the same way you saw, when we bring the south pole of this magnet closer to this magnet to the same side, they repel. Right, children? So in this case, we are sure that because they repel, this is the south pole. So if this side is the south pole, we can mark the other side as the north pole. So if you are given an unmarked magnet or a magnet wrapped like this, now you know how to identify what is the north pole and what is the south pole using another magnet. Right. So after doing the activity in the lab, I hope it's very clear how to identify the poles of an unmarked magnet using a given marked magnet. We'll move on to the next. We are going to do the next activity. Let's identify a magnet from different objects. So after doing this activity, we are going to prove that magnets behave different than other objects. Okay? So let's identify a magnet from different objects. So what do we need to do this activity? We need an unmarked bar magnet, a marked bar magnet, an iron nail and a pencil, right? Let's write. Unmarked bar magnet Marked bar magnet iron nail and a pencil. Unmarked bar magnet, marked bar magnet, an iron nail and a pencil, right? Let's see how to do this. Okay, the method is take the above mentioned things near the north pole of the marked magnet and observe. Then move them near the south pole of the magnet and note down the observations. Tabulate your observations. You have to take the unmarked bar magnet, pencil and iron nail. Unmarked bar magnet and the iron nail and the pencil. Right? Unmarked bar magnet, iron nail and the pencil, you have to bring it towards the marked bar magnet. Right, like this. You have to first bring the north pole of the marked bar magnet towards each of these objects, right? Towards one pole of the unmarked bar magnet, towards the iron nail and towards the pencil. Then you have to bring the south pole of the marked bar magnet towards the same objects. Okay, children? We will do this activity now. Right, children? Now we are going to do this activity to identify a magnet from other objects. Okay? So to do this activity, we need an iron nail, a pencil, and an unmarked magnet. So I have wrapped this magnet so you can't see the poles of this magnet. And we need another bar magnet. So in this magnet, you can easily see the poles, the north pole and the south pole. Right, children? First of all, we have to bring the north pole of this magnet towards each object and we'll see what happens. What happens when we bring this magnet, the north pole of the magnet towards the iron nail? It attracts. Right. Now I will bring this close to the pencil. What happens, children? Does it attract? It does not attract. Now I will bring this towards the unmarked magnet. Now unmarked magnet also attracts towards the other magnet. Right? So iron nail attracts towards the north pole of the magnet. The pencil does not attract, and this unmarked magnet also attracts towards the north pole of this magnet. Now I am going to bring the south pole of this magnet towards each object. Okay, children? Look carefully what happens. First I am going to bring it towards the iron nail. Right. This time also iron nail attracts towards the south pole of the magnet. It's very clear. Now I'm going to bring this towards the pencil like before. What happens, children? Is there any attraction? No attraction. Okay, children? And finally, I'm going to bring it towards the unmarked magnet. What happens this time, children? This time it repels. Okay, children? So it's very clear this time when I brought the south pole of this magnet towards each object, what happens? The iron nail attracts, the pencil does not attract or repel, and the unmarked magnet repels. So earlier when I brought the north pole, iron nail attracts, the pencil does not attract or repel, and the unmarked magnet attracts. So how to identify a magnet from the other objects, children? You all know that some objects attract towards the magnets and some other objects don't attract towards the magnets. Right, children? So some objects like this iron nail, they always attract towards the magnet no matter what the side or no matter what the pole of the magnet is. See, even though it's a north pole or a south pole, it always attracts. And some other objects like the pencil, look at this pencil. Does it attract or repel, children? You can see it does not attract or repel at all. Right, children? So no attraction or repulsion. Right, children? So some objects easily gets attracted towards the magnets and some other objects don't attract towards the magnets at all. What about the magnets towards the magnets, children? You can clearly see that when I bring the north pole towards this unmarked magnet, it attracts. But when I bring the south pole towards this magnet, it repels. So not like the other objects, children. What happens with the magnets? They always show an attraction as well as a repulsion towards another magnet, like this. So when we bring the south pole towards this magnet, it repels. And when I bring the north pole towards the magnet, it attracts. Right, children? So in both the instances, I did not change the side of this magnet. Right? Always I brought the north pole and south pole both towards the same pole of this magnet. So remember, children, only a magnet shows an attraction and a repulsion towards another magnet, and some other objects show only an attraction and some other objects don't show any attraction or a repulsion. So that's how we can identify a magnet from another objects. Right, children? So you observed what happened. What did we do again? We had to use an unmarked bar magnet, an iron nail and a pencil. We had to check them with a marked bar magnet. So first of all, what we did was we brought the north pole of the bar magnet, marked bar magnet towards each of these objects, and then we brought the south pole of the marked bar magnet also towards these objects. So what did you observe? Shall we write down? So when you brought the marked bar magnet, when you brought the north pole of the marked bar magnet towards the iron nail, pencil and small bar magnet, what happened, children? So let's start from the iron nail. So when you brought the north and south poles, no matter what the pole of the bar magnet is, the iron nail always attract towards the bar magnet. It doesn't matter what the pole is. Right? Even though it's north or south pole, iron nail always gets attracted towards the magnet. Okay, so only attraction is there. So each instance we can write iron nail, we'll write attraction. Attraction. Okay, what about the pencil? Did it get attract or repel? No. It doesn't show anything, right? Neither attraction or repulsion. We can write down here each instance. Even though when we brought the north or south poles, no matter what the pole is, pencil did not show any change. It did not get attracted as well as no repulsion, right? Let's write. Neither attraction no repulsion. Okay, neither attraction nor repulsion. What about the small bar magnet, the unmarked bar magnet? When we brought one pole of the marked magnet, it attracts. When we brought the other pole, what happened? It repelled. Why does this happen, children? I hope this is very clear now. Let's take that when we take the unmarked bar magnet, let's say that when we bring the north pole, if they get attracted, we can come to a conclusion that this should be the south pole of the unmarked magnet, and this becomes the north pole. And the second instance, when we bring the south pole of this one, south pole of the marked bar magnet, what will happen? Because now this one also the south pole, this is the north pole. We don't change the side of the unmarked bar magnet, we change only the pole of the marked bar magnet. So the first instance you bring the north pole of the marked bar magnet towards a certain pole of the unmarked magnet. So if they get attracted, you can decide that this is the south pole, right? The second instance, you bring the opposite pole, so which means two south poles together. This time always repel each other because like poles repel, unlike poles attract. Therefore, when we bring a magnet towards another magnet, there will be an attraction as well as repulsions, right? So under one instance, we can write attraction. The other instance, we can write repulsion, okay? So small bar magnet, when moved near the north pole, or either way we can write attraction, repulsion. Okay, children? So iron nail always attract towards any side of the magnet, right? Iron nail always attract towards any side, any pole of the magnet, right? Pencil, to any pole, no attraction, no repulsion. But the small bar magnet, what happens? From one side, to one side attraction, to the other side repulsion. Okay, so attraction and repulsion both can be seen when we use two magnets. Okay, children, this is how a magnet is different from the other objects. Right, children? The other objects, either attraction, no any observation. But bar magnet, any other magnet, you can see an attraction and repulsion both. Okay? So look at this one. Now compare your observations with the following observations. This is the same thing. When you use the iron nail gets attracted to both the sides. Therefore, only an attraction is seen. What about the pencil? No attraction, no repulsion. Neither an attraction nor a repulsion is seen. What about the bar magnet? The small bar magnet, when moved towards the north pole, it repels, and when it is moved towards the south pole, it gets attracted. This attraction and repulsion both can be seen only among two magnets. Right? Only among two magnets, this observation could be seen. This is why magnets can be easily identified from other objects. Understand, children? We'll write this one. A magnet always shows both attractions and repulsions with another magnet. A magnet always shows both attractions and repulsions with another magnet. This is how magnets are different from the other objects. Understand, children? We'll move on to the next. The assignment. You're provided with an iron nail, a magnet and piece of plastic wrapped in pieces of paper separately, which means you can't see them. Suggest a way to identify them using a marked bar magnet. Now you are given three objects. Iron nail, magnet and piece of plastic wrapped in pieces of paper. This is very, very similar to the previous activity, children. The only difference is this time, these three objects, the iron nail, magnet and piece of plastic. You can't see any of them because they are wrapped with paper. But you have to identify what is the iron nail, what is the magnet and what is the piece of plastic using another bar magnet, a marked magnet. You have to see them. Now I hope it's very clear. After doing the previous activity, we can easily do this activity. So when it comes to the iron nail, we know that iron nails always get attracted to the magnet. So no matter whatever the pole you use, let's say that you have the marked bar magnet. Bar magnet has two poles, north and south poles. No matter what pole brought closer to this iron nail, what happens? Always only an attraction will be there. Right? A magnet, another magnet. Here, look at this one. Previously we learned that iron nails, only an attraction is seen. right? Which means iron nails always get attracted to both north and south poles, okay? When you consider another magnet, now we can't see the magnet because it's wrapped. But we can keep both sides of the marked bar magnet to the unmarked magnet. If when one side is kept, repulsion is there, the other side is kept, there's always be an attraction, which means there will always be an attraction and repulsion both when it comes to the magnet. What about the piece of plastic? Piece of plastic is as similar as the pencil. Pencil doesn't get attracted to the magnet in the same way. Plastic also doesn't get attracted to the magnet. Therefore, the same observation as the pencil will be there. Right? Neither attraction nor repulsion. Okay, children. So even without doing the activity, now we can easily understand how to identify the three objects that are wrapped. What is the iron nail? What is the piece of plastic? And what is the magnet? Okay, children. We'll write down. Iron nail, it will get attracted to both north and south pole of the marked magnet. It will get attracted to both north and south poles of the marked magnet, iron nail. Magnet, the other magnet wrapped, both attraction and repulsions can be seen. Plastic, piece of plastic, neither an attraction or a repulsion. Repulsion is seen. Iron nail, when you bring the two poles of the marked bar magnet separately, it will always get attracted to both north and south poles of the marked magnet. And the magnet wrapped with the paper, both attraction and repulsions can be seen always when you bring both the poles, okay? Plastic, neither an attraction nor a repulsion is seen. Right? Neither an attraction nor a repulsion is seen. Understand, children? So this is how, if these three objects are given wrapped with papers and you are provided with a marked bar magnet, this is how you identify the three things separately. Understand, children? So we have completed this chapter. We are going to move on to the next chapter now.